Hi everybody, welcome to Steve's Podgy Chemistry video number 3, Organic Synthesis Reactions. Okay, so some of you have asked for a flowchart of how things go in an organic synthesis reaction, or how things move between, how we move between organic molecules. So what I wanted to do was put together a video to help you understand that. So where we start is alkenes, right at the top. They're at the top of our chain. Now, alkenes can react with HX or X2, where that's a halogen, to form halides, alkyl halides. And alkenes can also react with water in a basic environment to form alcohols. Okay, so from here, from halides and alcohols, we can get to all of our other functional groups. So if an alcohol is reacted with an oxidizing agent, it forms either an aldehyde or a ketone. So aldehydes are primary alcohols and ketones are formed by secondary alcohols. Aldehydes are then further oxidized to carboxylic acids, so with an oxidizing agent. And remember, the reason this can occur is because the alcohol has the formula C or ROH. The aldehyde has R double bond R C double bond OH. So the first layer of oxidation is when that oxygen is added. So the hydrogen is removed, a double bond is formed, and that hydrogen is, and then the hydrogen replaces, then the hydrogen is stuck off. And then the second level of oxidation is that you then have R-C double bond OH, and that's our second and that forms our carboxylic acid. So a carboxylic acid plus an alcohol will form an ester, which is has that form. And that's the end of the line for this branch of our tree. Alcohols, so when alkyl halides react with alcohols, they form ethers. Ethers can also be formed by alcohols with sulfuric acid, but you end up with a symmetrical ether. Alcohols can also react with, so if they react with ammonia, you form an amine. And remember, you can have primary, secondary, and tertiary amines. So that, and the primary, secondary, and tertiary nature of the amine refers to just to whether the hydrogens on the nitrogen atom are replaced by carbons or not. So a primary is RNH2, a secondary is R, N, H, R prime. And then a tertiary is R, N, R prime, R double prime. So we've got two different R groups attached to that nitrogen atom. All right, where else are we going from here? So halides can be converted to alcohols in a basic environment if water is present. If water is present, halides can also be converted, so a halide and an alcohol, sorry, a halide and a carboxylic acid can also form an ester. So if you've got a carboxylic acid and a halide, an alkyl halide, you can also form an ester, and it'll form in that same branch where this portion of the atom, this whole portion comes from the acid, and the R group comes from the alkyl halide. What else do we have on our magical mystery tour? An ester can form a ketone. So an ester goes to a ketone if we take off one of these oxygens using a strong reducing agent. So that leaves us with this oxygen being removed. So that oxygen's removed. The R group links to that carbon, and you end up with R carbon double bound to oxygen R prime. That's R, C, R prime. Carboxylic acids can go back to alcohols with a reducing agent. So if carboxylic acids are reduced, the oxygen is removed, one oxygen is removed, and we return to the alcohol, and then esters with a strong alcohol will cleave the bond with a strong oxidizing agent, will cleave the bond, and two hydrogens will be added as well. I think that's all for the time being. If you have any questions, please put them in the comments. Thanks for watching, guys.